right, we are going to do lesson 7, which is solving for a variable. This is also sometimes called a literal equation. So let's quickly go over the notes. Sometimes in math, we need to solve for a variable. All that means is we're going to take the equation and we're just going to reorganize the equation. There's no solution. We're just rewriting the equation in a different way. Some of the reasons that we like to solve for an equation, oftentimes in algebra, and we'll do this later on in a different unit, we're going to reorganize linear equations to get them into a different form. A lot of times in science, you're doing repetitive calculations, like you're doing a calculation over and over and over and over again, and instead of having to reorganize the formula each time you do the calculation, you do it at the beginning, and then it makes all your calculations easier. So here are some very common formulas that you might see while you're reorganizing some of them. Let's see, perimeter of a rectangle. That would be 2 times the length times 2 times the width. Circumference of a circle, we'll be doing a lot with that later. That's 2 pi r. Area of a triangle, we did that last year. Base height times, or divided by 2, or 1/2 base times height. Area of a circle is pi r squared. We'll be doing that later. Distance traveled, d equals rate times time. That's going to show up later. And temperature, only one left is that one. So these are some common formulas just to kind of keep in the back of your head. Turn your page and we're going to go over how to change up an equation. Now, before we do that, just a caution. Does a variable that's used in multiple formulas always stand for the same thing in all formulas? No, that is not true. A lot of times we'll use different variables over and over and over again, and they might mean length in one equation, and it might mean something else in a different equation. Okay, you can go over that example. But basically what we're doing is we're trying to unravel this equation to get a specific variable on one side of it. So I have the example number 1. 5x equals negative 4y plus 4. I want to solve for y. That means I want y equals blah. And this is not going to look pretty. Well, the first thing, if I want to get y by itself, I need to get rid of that 4. So I'm going to subtract 4 from both sides. I get 5x minus 4 equals negative 4y. Still want to get y by itself, so I'm going to do the inverse of multiplication, which is division. I'm going to divide by negative 4. I have to divide this whole thing by negative 4. And I'm just going to write that to make it look pretty. Y equals 5x minus 4 in my numerator, negative 4 in my denominator. That is the equation. Notice there's no answer here. I don't have like y equals 17. It's just the equation rewritten. Example 2. mx plus nx equals p, and I want to solve for x. I want x equals blah. Well, I noticed something here. M and n, I know that these are kind of like terms in a way because there's x in both of them, but I can't really add m and n. That's confusing. What I want to do here is I want to try to get x by itself. I'm actually going to pull out or factor out the x. So I'm going to factor out the x. That means the opposite of the distributive property. So that means here in this term, x times what gives me mx? M. And x times what gives me nx? Positive n. So mx plus nx is the same thing as x times m plus n. I just did the distributive property opposite. Now I have x times this funky thing. I'm going to divide by this whole value. And I have x by itself. X equals p over m plus n. So that's a handy dandy little trick. If you have the variable in 2 different terms, you can't really combine them. You can factor out that variable. Number 3. X plus 2 over y minus 1 equals 2. I want to solve for x. Well, I have x in my numerator. I want to get rid of my denominator. So I'm going to multiply everything by x minus 1. So that means those cancel out. X plus 2 equals 2 times Oh, sorry, that was a y minus 1. I'm getting sloppy. And I'm going to factor that out, or distribute that. And I'm almost have x by itself. I'm just going to subtract 2. And I get x equals 2y minus 4. Oh, that one actually looks kind of nice. All right, next one. 2 times x plus a equals 4b. I want to solve for b. Oh, well, all I have is 4 times b. I'm just going to divide everything by 4. By 4. And I have 2 divided by 4. That just becomes 1 over 2. So I have x plus a over 2 equals b. Oh, well, that one was nice. Let's do a couple more. Y equals x minus v over b. I want to solve for x. Ooh, x is in my numerator. First thing I have to do is get rid of the denominator because my numerator, it's kind of like I have invisible parentheses around my numerator. So I'm going to multiply. This is being divided by b, so I'm going to multiply by b. Multiply by b. I get b times y, or y times b, equals x minus v. Trying to solve for x, so I'm going to add v. And I have by plus v equals x. Or x equals by plus v. And last one for here, dirt. This is our distance formula, d equals rt, dirt. I want to solve for r. We're going to be doing a lot of that in later units. Well, this is r times t, rate times time. So I'm going to divide by t, and rate equals distance divided by time. We're going to use that formula a lot. So take a moment and do Pizzazz page 72, which is this one. And then I'm going to go ahead and go over these challenge problems in the next video.